Hey you, are you interested in learning MATLAB? Probably not, but are you being forced to by either professors, co-workers, or maybe it's just something you're passionate about? Well then do I have the solution for you. But first, the MATLAB Bible. So here we are in MATLAB. We have the command window open. I'm hoping that you know how to install MATLAB. It's really not difficult, so I'm not going to cover that. So we're in the command window. What we're going to have to do in order to start making our first file is we want to come over and hit new script. That's going to open this editor basically and move the command window down there. So first thing we want to do is we want to save this and we want to name it to just whatever we want. So we can call it as soon as we give it our name. That's essentially what this script is going to be referenced as. So let's first talk about assigning variables. So what we're going to want to do, we just hit like a is equal to 5. It's really that easy. We can hit run. You'll see that a is in fact equal to 5. And then if we want to hide that so that way when we run it that doesn't show up, we can just put a semicolon. You can also comment. Basically commenting, you just put the %sign and just, I don't know, type in any kind of description you need, I guess. So another thing we can do is we can also set a variable equal to a string of text. So in this case we can do like b is equal to just any string of text basically. As long as you put the apostrophe, anything that is in between those apostrophes is going to come out as text. You can hit run. You'll see that b is equal to that. So vectors. Now vectors are pretty straightforward. We can create something like a row vector, and so what we can do is either you can define a vector by putting spaces in between each element of the actual vector itself. So you can do like 1 space 2 space 3, put the bracket because that signifies that it's a vector basically. You can create a matrix if you put a semicolon here and then you do basically the next row of elements, and then you can see that will show up as 1 2 3 4 5 6. Now if we want to do some general math is pretty straightforward. It's about as easy as it sounds. The only thing you really have to worry about is when you have vectors and matrices involved. You need to basically implement something called a dot operator, and I'll show you what that is. So you can do like d is equal to, now if you want to multiply a by every single element in C and basically create a new array from that, what you'll do is you'll do dot times C, and we'll see that d is equal to a times C. So we can close that off because we don't want to see that anymore. So another thing that you can do is you can actually print entire statements out, and this is really useful for if you have a variable that you want to basically just state the value of that variable, and like if you're trying to just have some kind of plain text sentence show up across the command window when you run it. And the command for this is going to be fprintf, and then you will put a parentheses, apostrophe, close it off with the parentheses, and now anything in this apostrophe is going to be shown as plain text. Now we get to where we want to define our variable or state whatever value we want, right? So let's say put our value for a here. What you'll do is you'll do %. You can basically declare like how many decimal points you want to use. So if I just want to, like, I don't know, have like 2 decimal points, I'll just put 0.2f. That's definitely not a percent. So that's basically it. And then if you want to go to a new line, you'll do \n. Also, after your apostrophes, you have to designate what variable gets chosen. So you'll put a comma, and then you can basically designate the variable. Now, if we run this, you'll see I will give you, in fact, $5 if you bring my kids back. So next up, we're going to want to make a plot. We can just do a regular linear plot or whatever. I mean, literally anything you want. So firstly, we'll just designate a linear vector of values for our x-axis, and we can just start at 0. And what we can do is we can go from 0 to, I don't know, 10, and then we can go in steps of 0.1, and then our y values, what we can do is we can do any function, basically, any set of values you want to plot against your vector x. So in this case, what we'll do is we'll just do like x to the power of, and don't forget the dot operator, do x to the power of 3, I guess, and then we can do plus 20. So now that we have both of our data sets, in order to plot it, you just want to type plot x against y, and then fancy this plot up however you want. So for example, if we want a red line instead of a blue line, which is the default for MATLAB, you can just type red here, put a parentheses, that will make it a red line, and we can see that here. So if we want to do, we can make our x label right here, and you're basically just going to make in this same format. So we can do like hours spent studying, and then we can do our y label, which is going to be, oh, I don't know, we'll do like something just simple like that. That's not right. Hang on, let me fix this. There we go, that's better. That's more like it. So now we have that, and we can get this shit out of here. We're done with the plot. We can just comment that out. Let's go on to if statements. So for example, if I can make a new variable up here, call that sub, that'll be 0. Basically, what it's going to do is if you are subbed to me, sub is going to equal 1. So basically our if statement is going to check to see that sub equals 1. And if it does, we're going to take me, set me equal to happy. All right. And then what we can do though is if it's not equal to 1, we still want it to run some kind of protocol. So we can just call that else and basically set whatever that's going to be equal to if it doesn't meet that prior condition. What we can do is once we're done with our if statement, we can end it. So you'll see that sub is equal to 0. We get some red lines here, which is not good, but that's because this statement cannot be reached. So what that means is that at the current moment, sub cannot equal 0, but I can make that turn into 1, and the way we're going to do that is with a while loop. So we're going to have while sub is less than 0, or less than 1, sorry. So while you are not subbed to me, the protocol that we're going to follow is we're going to take sub, we're going to take the current value of sub, which in this case is 0, and we're just going to add 1 to it. Easy enough. And then we're just going to end it. So what that's going to do is while the value of sub is less than 1, it's just going to take that, add 1 to it, and then it's going to check it again. So then once it actually greater than or equal to 1, it will see that and it won't run any of this and it'll just end. So what we can do is we can put another equal sign there. So then what we can do is we can run that and we'll see that me equals happy. And the reason why me equals happy is because if we check the value of sub, we see that sub is 1. Now that we're done with that, we'll just put some semicolons there. Easy enough. So now what we're going to do is we're going to talk about for loops. For loops is honestly very similar to something like a while loop. but a while loop is ran for if you don't know how many iterations of the actual loop you're gonna have to do, or it's not like a clearly defined number of iterations. But a for loop is done when you actually know how many iterations you want. So for example, I can do for every value between 1 and 10, and then go in steps of 0.1. So for every iteration here, I can take, we'll do like f is equal to a, we have to set this equal to a variable because it needs to know basically at what iteration it's on. So you can do a times e and then just end it. So then what we'll see is that f is going to run. Lastly, we're going to talk about functions. What you're going to want to do is you're going to want to come over here to new, and you're going to hit the drop down arrow, go to function. It's going to pull up this is going to be your function up here, and you'll see that it's denoted by the actual word function. So you have your output arguments. This is just the output of your function. It can be as many outputs as you want or as little outputs as you want. Have the name of the function up here, and then your input arguments, once again, as many or as little as you want. You can even have 0. So in my case, for this example, we'll just do our output, and then we will take our input, and our input, we'll just make that based on, you can call it literally anything you want, because anything you do put input into the function will get renamed while it's being used. Our input argument, we'll just do like, then here it already does like a nice little layout, so you can write an explanation of what the function does. We don't need that because fuck that. This is just whatever. So we can move on to the math. What we're going to do is we're not really going to do a whole lot just for example, or for the sake of it being an example. We'll just go straight to the output. We'll define our output as our input times 50, and this is assuming our input's going to be like on a scale of 1 to 10, right? So that's pretty much it. Just make sure you save your function as the same name that you defined it as. Once you save that, you're basically ready to call on it. So what you'll want to do is you will then come to your main script, and you'll call upon your function. So your output doesn't need to be the same doesn't need to share the same name as your function's output, but for this case I am, just because it's relevant. And then you want to type out your function's name, and then you'll want to basically just drive your input into that. So for our input, I'll just take the 4, or the last value of the 4 right there. Easy enough. And then we can run this and we'll see that our function works. It does exactly what it says it does. It takes our input value of 10, multiplies by 50, and then we get our output, which is then sent back to our main function, which then we can use in whatever way we want. But yeah, that's about it. Honestly, I wouldn't say I use MATLAB in any further extent than that. This is pretty much the fundamentals of it. Anything else you can kind of look up and figure out just from looking at the old MATLAB Bible. Anyways guys, I hope you enjoyed, and in the next episode we're going to be looking at how to build Minecraft from scratch using MATLAB.